Hey there guys, so today we're going to try out how can we bypass the DEP protection when we want to execute our shellcode. So as we know that when we want to perform buffer overflow, we just use a jump ESP to jump into the stack and execute it at the stack, right? But with data execution prevention, this DEP enabled, it doesn't let us to execute our shellcode in the stack. So this one, as you can see, that I turn on the DEP for essential Windows program and services only. So I still haven't turned it on for all programs. So today we're going to try out. We are going to execute the shellcode at VUPlayer by abusing the buffer overflow when we want to open the playlist. For this version, it's vulnerable to the buffer overflow when we want to open the playlist. So we're going to try it out. Over here I've written a script, a simple script that without bypassing the DEP one. So this one, this is a shellcode, the jump ESP now plus the buff, which is the shellcode. So I'm gonna write it to poc.wax. This is the playlist. So okay, we run this one. Okay, over here, this is the file. We're gonna open VUPlayer. We open the playlist and then we select poc.wax. As you can see, the calculator just pop up. So this one, we still haven't enabled DEP, right? Later on we try out, we turn on DEP for all programs, and then we try to find out how can we bypass this one. One of the methods that we can bypass is using return oriented programming, or we call it as a ROP. So we're gonna try it out. Turn it on. We need to restart the PC. Close all this one first. Okay. We wait for the PC to on. Okay. Now we wait for all the programs to enable the boot up first. Okay, so we check it out again. DEP, yeah, turn it on for all programs. So now we try the same exploit again with DEP protection enabled. So press this one, and as you can see that the calculator doesn't spawn, right? Because DEP has protected it, so we can't execute our shellcode inside the stack. So right now we need to find a way to bypass DEP. We can use ROP. Okay, so now we're gonna start from the root point, from how can we create the exploit. So here I create a file first, name it as exploit.py. Okay, there's a file here. I delete this one first and I create now another one. Okay, now edit it with this one, import struct, and then open. This one will be the, as you can see that over here, these are all the extensions that available that is support. So right now we're gonna use WAX, this extension. Okay, put test.wax and then we put W over here. F.write what we want to write. Over here we put jump. Now we want to check it out, how much the input to make the program buffer overflow. So we put 2000, test it out. Okay, so over here payload is done. Okay, is the payload. Okay, after close, we save this one, double click it. So this is the file. Right now we open up our immunity debugger and then start the program. We attach it to VUPlayer. Okay, and then we play this one. Right now we're gonna open the playlist and we're gonna import it. Play. Okay, seems like we have overflow until the EIP. So this, as you can see over here, A, everything also A over here. So we have overflowed it. Right now we want to create a pattern to find out which offset is it. So we can use Mona. Okay, so in this case we're gonna use the, what's the pattern? Yeah, this one, the pattern create. So we use the pattern create, we create 2000. Okay, so it's safe at this path. So I'm going to go to the path. Okay, so this is the pattern. I place it over here. This one. Okay, save it. Right now I'm gonna run this again, and then over here I'm gonna restart it. Okay, close error, restart it again, play everything else, and the program start. Now open the playlist, click on the test, and we play. Okay, so this one is 68423768, right? Now we're gonna use the pattern offset. Pattern offset 68423768. So the pattern shows that the cyclic pattern is at the position of 1012. So over here our junk will be 1012. This one, remove everything else. Junk will be 1012. Right now we're going to check it out. What are the bad characters that we mustn't include in the shellcode and in the ROP? Okay, so right now we put that car. For bad characters, we can use the byte array. So these are all the byte array. We get it from here. So over here, plus the back card, as we know that 00 will be the string terminator, so this one definitely gonna be a bad character. So we start from 1, close this one, and then need to start the process again. Okay, play everything else. Okay, so now go back to here, rerun the script again. So now go to here, open a playlist, play everything else. Okay, so now over here we go to the dump ESP, follow the dump. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 is missing. Okay, so seems like these are the places that have the bad characters. So over here we test it out by removing 9. Try to check it out, is this the one? And then I'm gonna restart this one again, run the script. Oops, play everything else. Okay, open the file, click on the test, play it. Okay, follow the dump. It seems like 09 is not the one. Okay, so now we check it out again. We remove 08, replace 09 over here again, replace it with 08. Back character 08, probably this one. Okay, create it again. Open the playlist. Okay, follow the dump. Okay, it seems like 08 is a bad character because 09 has appeared over here. Okay, now we follow the dump. 19, stop at 19, then missing. So try to remove 1A and see. There's the 1A. After 19 is 1A. We remove this one, we place it over here. Okay, so now we need to restart it. Then execute the script again. Play everything else. And then over here, need to follow the follow the down. Need to open the playlist again. Go to desktop. Okay. Play. Okay. Follow the dump again. Dump ESP. Now we need to trace over here. Does it end or not? Okay. 7, 8, 9, D, A, B, C, D, E until FF. Yes. So now we'll find all the bad characters over here. So right now, the next thing we need to do is that we need to find the ROP. Before we need to find the ROP, we need to check the modules first. So, oops, not this one. Let me restart the program again. Play everything else. Okay, we find the modules. So over here we need to make sure that we need to find the modules ASLR must be false, because if not the address gonna be randomized. So we need to make sure it must be false. Okay, so back character, we found it. Now we need to note down what the DLL. So this one is ROP chain. The first one will be base wma.dl. The second one will, the first one is this one, base wma. The second one I'm going to be selecting base.dll because this one is so false. Yeah, this is base.dll. Okay, so now we need to use Mona room. Is there any help menu for it? Seems like it doesn't have. Never mind, we check it out. Because we need to specify the back characters. Seems like my machine crashed already. We need to wait for it for a while, yeah? Okay, so now we find Mona ROP specify back characters. Because if we didn't specify the back characters, it's going to terminate our whole ROP chain. Is this the one? Yeah, I agree. Wanna suggest? Yeah, this is the one. This is the one that specifies the back characters. So over here we close this one. Okay, it seems like I'm gonna force close this one. Now you're gonna waste a lot of time. Close it. Okay, so now combine our immunity debugger, VUPlayer, enable it. Okay, now we attach the process again. Play it. Okay, so this one it plays ready. Oh, now we're gonna use ROP, and then we're gonna specify module, the DLL. So here we got two DLL. I'm gonna use the ROP chain to chain these two DLL together, and then this one .dll, and then another one is base wma.dll. And then this one cpb, this one will be the back characters, which will be this one. Okay, so now enter. Oops. What's the problem over here? Non-hexadecimal found. Is there any non-hexadecimal? Okay, seems like we can't specify the comma over here. So now we wait for it to search for the ROP chain. Okay, we click this one to check the log. So ROP generator finish generated. We go back to here. We select the ROP chain. This file. Okay, so this is the register setup for it. The ROP chain. Okay, so this one is the instruction. We're gonna use for Python. ROP is okay. So for ROP, actually it's just for return. Return. As you can see, most of the instruction over here it end up with return. That's why they call it as a return oriented programming. So we're gonna try to use this one. Place it over here. Okay. Place it over here, this one. And then we need to place the ROP chain over here. And then we need to put some knob over here, because we need to give it some memory over here between the ROP chain and our shellcode. So knob, put 16 byte for it. Nope. And then we're gonna put our shellcode. This one we're gonna execute this one with access random. So we're gonna execute for calculator, and then the back character gonna be this one, 0A and 1A. This one 0A 1A. Okay, and then the file output gonna be Python. So we leave it to generate the shellcode first. Okay, so these are all the shellcode. Place it over here. Buff. We save it. So now we're gonna test it out. Does this one work or not? And go back to CPU. Okay, and then this one. I want to change the name. Exploit. Okay, we run it. Back car is not defined. Okay. So over here we need to put junk plus our rope chain, which is this one, rope chain, and then the knob. We give it some space over here. Only we reach our shellcode to execute the calculator. So we're gonna try and check and see, can we use this method to bypass the DEP protection or not? Okay, we run again. So now we go back to here, open the playlist, go to desktop, select exploit, we play it. Okay, voila! It seems like we successfully bypassed DEP protection by using ROP chain method. So we have spawned a calculator over here. Okay, now without using the debugger, we try to use this method over here. Okay, remove this two file. We click on our aspect, double click it. Okay, we generated this one, the playlist file. We click on open, select this one, and now we have successfully bypassed DEP protection to execute our shellcode. Okay, we try to check it out with the normal one, which is this one. Double click it, open this. As you can see, this one is a non-DEP bypass method. I didn't use the I didn't use this one, the ROP chain method, to bypass it. So as you can see, this one doesn't work. But over here we have created a ROP chain method to bypass it. So that's how we can exploit it. So that's all for my videos. Thanks guys. Bye.